Hi, this is the next video for Year 13 Maths. We're looking at teaching for exercise 9H, implicit differentiation. So this is, hang on, let me write it first. This is the idea that if I have a function in y, but I want to differentiate it with respect to x, I use the chain rule. And I multiply by dy dx. So every time I have an expression in y, if I want dy dx, I differentiate with respect to y and multiply by dy dx. And that's useful where I have a function where I can't necessarily make y the subject. So now I have a function in x and y, and I can't make y the subject explicitly. So I differentiate everything with respect to x. I differentiate the whole function with respect to x. So 3x squared plus 1. If a function is in y, I differentiate it with respect to y and multiply by dy dx. And of course on the right hand side, differentiate a constant with respect to x. It goes to 0. Take out a factor of dy dx. And then I can make dy dx the subject. And not surprisingly, because my initial function, where y is not explicitly the subject, my initial function, if you like, is a mix of x and y, then my expression for dy dx is a mix of x and y. And that's not an issue because given the x coordinate, I can find the y coordinate, so I can still find a value of dy dx at a particular point. Occasionally, let's have a look at this one. We have to apply the rules that we have looked at before. So here I've got a product of 4x and y squared, so I'm going to use the product rule here. Here I've got a quotient, so I'm going to use the quotient rule. So if I differentiate 4xy squared, well, my product, so u is 4x, u dash then is 4, v is y squared, v dash is 2y dy dx. And remember the product rule is u dash v plus uv dash. So my derivative, u dash v, 4y squared plus u v dash 8xy dy dx. And I'll use the quotient rule to differentiate the second term. Derivative of 6x squared over y. Here, remember, u is 6x squared, u dash is 12x, v is y, v dash is, well, y differentiates to 1, but remember we multiply by dy dx, because dash really just means differentiate with respect to x. And the quotient rule, u dash v minus uv dash over v squared. Remember we are given that. So u dash v, 12xy, uv dash, minus 6x squared dy dx, all over v squared, all over y squared. And I'm going to simplify. 12xy over y squared is just 12x over y. And then 6x squared over y squared, I'm just going to write it slightly differently because I just prefer the look of that. The the question wants, oh sorry, so I've got 4y squared plus 8xy dy dx plus 12x over y minus 6x squared over y squared. The right hand side equal to 10. So of course that differentiates to 0, whether it's with respect to x or not. Now the question wants the value at the point 1, 1. So at this point I'm going to sub in x and y both equal to 1. So what do I get? 4 plus 8 dy dx plus 12 minus 6 dy dx equals 0. So 8 dy dx minus 6 dy dx is 2 dy dx. 4 plus 12 is 16, so let's take 16 off of both sides. And so dy dx is minus 8. My preference is, once I've differentiated, rather than making dy dx the subject here, rather than making dy dx the subject here, I'm just going to sub in straight away, so I'm not likely to make any mistakes in my rearranging. Sub in as soon as you can, and then rearrange or solve later on if you need to. And the last example is same again with arguably a more complex function. Find dy dx at 1, 1 again, where e to the 2x log y equals x plus y minus 2. So e to the 2x log y, we can see straight away that's a product rule, so let's set my u is e to the 2x, u dash is 2e to the 2x, v is log y, remember log differentiates to 1 over y dy dx, and my product rule is u dash v plus uv dash, so 2e to the 2x log y, 2e to the 2x log y plus e to the 2x over y dy dx. That's my left hand side. X differentiates to 1, y differentiates to dy dx, and minus 2 differentiates to 0. Again, I'm going to sub in first before I rearrange anything. 2e to the 2 ln 1, log 1 I know is 0, plus e to the 2 over 1 dy dx equals 1 plus dy dx. So yeah, log 1 is 0, so I get e to the 2 dy dx equals 1 plus dy dx. So I'll take my dy dx over here, factorise, and then divide. So dy dx equals 1 over e squared minus 1. So fairly straightforward. The learning point is, if I have an expression in y and I want dy dx, I differentiate with respect to y, multiply by dy dx. Okay, have a go at 9h please, and I'll see you next time.